Hello everyone. Welcome to this presentation on software development life cycles. My name is Rumesh Jetunga, an agile coach by profession as well as by passion. I'm the agile coach at Wiley Global Technology Private Limited, and I am responsible for agility at offices in Sri Lanka, Asia, and Australian region offices. I have over 16 years of industry experience, having worked in different capacities from software engineer, web developer, business analyst, project manager, to becoming a CIO of an IT company. I'm also a part-time lecturer, having more than 7 years of lecturing experience at multiple private universities here in Sri Lanka. I've taken my career in a new direction of entrepreneurship, as well as have been driving transformation and capacity building engagements through my own company, Aptra Holdings Private Limited. Aptra is a transformation consulting company specializing in training, consulting, and coaching on the areas of agile, scaled agile, project management, business analysis, and management 3.0. By now, you should be familiar with our color coding system. Let's see what exactly is a life cycle. It is a common property for anything in the world. A plant, a human being, and every living creature have a life cycle, including birth, growth, maturity state, decline, and finally a death. Each stage has its own unique characteristics, operations, and transitions, which makes the study of life cycles an interesting proposition. We saw that entities in the real world have a life cycle. Software is no different. Software too has a birth, a growth, a maturity, a decline, and finally a possible death. Software development life cycles, or SDLC, provides a framework that describes activities performed at different stages of a software development project. It splits software development work into distinct phases containing activities with the intent of better planning and management. The aim is to create high-quality software that meets or exceeds customer expectations, reaches the completion of work within the timelines and budget estimates. Software development process, system development methodology, software development methodology, software process are some words used interchangeably to represent SDLC in the industry. However, it is important to remember that a life cycle is definitely different from a framework, methodology, or an approach. SDLC is normally aligned with the project management approach. The SDLC will help to plan and execute a project in an appropriate manner. The SDLC will assist in creating a shared understanding and an alignment between business and technology teams on what must be done and why. It will help business and technology teams determine what must be done and what should not be done. Software development is not just about coding and testing. It requires a certain amount of activities and deliverables related to requirement solicitation, analysis and documentation, aspects of design, and an organized approach to deploy and maintain solutions. Hence, SDLC will create alignment, transparency, and visibility across all stakeholders right throughout the initiative, thus providing the opportunity to obtain metrics and measurements for continuous improvement. The SDLC consists of different stages. In this presentation, I will take you through 7 distinct stages in SDLC. However, do note that you will find SDLC models with 5 stages, 6 stages, 8 stages, and even 10 stages when you do some additional reading on the internet. The planning stage, or the gathering of requirements and analysis stage, consists of activities and deliverables related to identifying the problem or business need, performing feasibility studies to ascertain the viability of the initiative, identifying the scope and objectives of the solution, eliciting and analyzing requirements by creating appropriate requirement specifications and models, to planning out and securing human and non-human resources, including funding required to get the project done. The design stage is the key precursor to the main development stage. The developers create the outline of the solution, including user interfaces, system interfaces, network and hardware requirements. Databases and other solution-related requirements are determined during this stage. The actual coding of the software, according to the outline specifications and design documents, happens during the development stage. Developers focus on following coding guidelines and engineering best practices, learning and applying new technology and tools, and on building robust solutions that show quality aspects related to non-functional requirements. Developing the software is not the end. Now, the software must be tested to make sure that there aren't any bugs and the end user experience will not be negatively affected at any point. During this stage, the developers will go through the code against the quality aspects mentioned in the requirements documentation, while the quality engineers will further check the solution against the test cases they have written. The software components will come together and be deployed in staging, followed by the production environments. The staging environment is normally used to carry out end-user testing or UAT, while the solution in the product environment theoretically means that the solution is ready for the market. The SDLC does not end when the software reaches the market. The developers will now move to maintenance mode and start handling issues, bugs, and requests reported by end users. The users may also request enhancements or requests for changes, and handling those two are of the interest of the developers. There are so many SDLC models created by software development experts and standard organizations around the world. Each model has its own unique structure and follows a series of steps unique to its type. I will talk about a few SDLC models starting from the next slide. The waterfall model is the oldest and the most well-known SDLC model. It was introduced around 1970. The waterfall model is suitable for projects that focus on fixed requirements. It is a linear, sequential flow coming steadily downwards like a waterfall through the phases of software implementation. A phase in the SDLC will begin only if the previous phase is completed. The pure version of the waterfall model does not include the process to go back the previous phase to handle changes in the requirement. However, a variant called recursive waterfall model allows to move back to previous phases and fix any problems or issues in such stages of a project. The waterfall model is easy to be explained as its stages, activities, and milestones are well defined. Each phase of the project has clear deliverables, such as the SRS document as the deliverable from the requirements analysis phase. The waterfall model, however, is inflexible and costly, as it may require more time to adjust scope, time, cost, or any other parameter. All requirements must be fully specified upfront, while deliverables created for each phase are considered frozen. The term waterfall can give a false impression of progress, and it does not reflect the problem-solving nature of software development. The integration of components is one big bang at the end, and customer involvement happens only at the end. Because of that, the risk of solution being rejected by the customer at the end is quite high. The iterative model is developed to overcome the weaknesses of the waterfall model. It is used to shrink wrap the software system and build it as small phases or segments. There is a phase upfront to do the planning and requirements gathering, while in the subsequent stages of design, development, and testing happens as cycles. At the end of each cycle or iteration, some output is created, which will then be integrated and deployed as a subsequent stage. The iterative model allows for a phase-wise approach and thus eliminates the problem of stage-wise visibility and Big Bang implementation that we saw as a problem in the waterfall model. The spiral model is a risk-driven iterative model that divides the project into iterations. Each iteration deals with one or more risks. Each iteration starts with a small set of requirements and goes through the development phase for those set of requirements. The cycles in the spiral continue until all major risks are addressed and the application is ready to be deployed to production. Each of the iterations prior to the production version is a prototype or a working model of the software. The spiral model is suitable to develop the software for high risk and mission critical types of projects. Its nature allows early indication and handling of risks. The users see evolving parts of the system early, and this allows the users to be close to the lifecycle stages of software development. The disadvantages of the spiral model are that it is complex and involves multiple rounds of planning, setting objectives, risk analysis, and prototyping. If not managed properly, the spiral can go on forever. V model is the model similar to the waterfall model. It is also used when the requirements are clearly defined and known, as well as when the development tools and technology are well known. It is actually an extension of the waterfall model, where instead of moving down in a linear way, the process steps are bent upwards after the coding phase to form the V stage. The V model focuses on the verification and validation or testing phase for each corresponding development stage. In order for the V model to be successful, the acceptance test design, the system test design, the integration test design, and the unit test design should be done as early as possible. In other words, the objective should be to shift test left and make the V as narrow as possible. The Big Bang model is a SDLC model that starts from basically nothing. It can be coined as the simplest model in SDLC and does not follow any specific process. It requires no planning and the development just begins with the required money and effort as input. The Big Bang model is suitable when a customer is not sure of what he or she exactly wants, and the requirements are good to be implemented on the fly, as and when they come without much analysis. The Big Bang model is suitable for small projects, where the size of the development team is very small, typically 1 or 2 developers. Evolutionary prototyping is a software development method where the developer or development team first constructs a prototype. After receiving initial feedback from the customer, subsequent prototypes are produced, each with additional functionality or improvements until the final product emerges.